lesson that we have so that we must do our presentation, or we started our presentation based on the circuit analysis. Now, I know that some of you have went through circuit analysis, whereby we look at the flow of current. Now, I will take a circuit as an example, whereby we look at that circuit all just together, and then with that circuit, then we try by all means to analyze it to a point whereby we see what is a parallel circuit and also what is a series circuit. How do we define a parallel circuit and how do we define a series circuit? Now, whatever I'm going to go through with you, it is something that already you have done, or something that already you have been taught to do on the online session, isn't it? You have already done series parallel circuit, right? Mm. Then your response, it will be very helpful to me so that I can know what is it that we need to do. I need to step on top of what you have done or what you are busy in. That is what I need to do. Am I making myself clear?
So, actually, there is other components like not circuit analysis on blackboard computer, but like me, I got this like just at the end of last week. So it's not like I know everything, and I know it's there, and I just need to catch up and everything that you're going to do.
Okay, let me first start by asking this question. Have you done series parallel circuits?
Yes.
Someone? I'm talking about the one. Remember, this is the content which is assigned for the subject. The second analysis. I'm talking about electronics. That is the first section, the extra notes. Remember on your on blackboard, on your study guide, the first section is the extra notes, then comes chapter 1, then comes chapter 2, chapter 3, chapter 4, then chapter 5. Have you had already, or have you done already, circuit analysis? No. On the online, remember that's why I said there are 3 assigned to you. No. 1, face-to-face, which is me, communicating with you. 1, online, then the overseer. Now, with the online session, have you started? No. According to individuals, no. Okay. But there is a bit of information that you know, right? No. I'm talking about the content. There's a bit of information that you know, right? Mm. Or are you an empty team? No. Let's get this straight. Are you an empty team or are you a team filled to a certain level? Which one is it? An empty team or a team filled to a certain level? An empty team. Remember, an empty team means the loudest noise. So, where are you? Are you an empty team or a team to a certain level?
Team to a certain level.
Team to a certain level. Mm. So which means I am going to increase on top of something which is already there. Okay. But now if I'm increasing on top of something which is already there, then we have to communicate. Remember, here there's no answer which is incorrect. There is no answer which is incorrect. Every answer is correct, it's just the time, no, the place. Okay, now let's look at the circuit analysis. Now you will see that when you do circuit analysis, you look at the Kirchhoff's law, it looks at the flow of current based on your circuit connection. Now, I have got an example circuit that I'm going to use with you so that we can understand how we do the analysis of these. Now, when we do the analysis of these, we are going to do the analysis of these looking at the voltage measured across the component and the current which is flowing throughout the circuit. But when we do that, we need to go and check what type of circuit do we have. Now you'll see that in circuit analysis, it says it consists of two types of circuits. You have what we call a parallel circuit, and you have what we call a series circuit. Now, how do you define a parallel circuit? How do you define a series circuit? How do you define a parallel circuit? How do you define a series circuit? Now, you see that the definition of those two, it is based on your Kirchhoff. Then it goes and says a parallel circuit is a current divider circuit. A parallel circuit is a current divider. I think just give me now. Oh, a parallel circuit is a current divider circuit. Then a series circuit is a voltage divider circuit. Now, how are you going to identify that this is parallel and this is series? Then it says on a closed loop circuit, on a closed loop circuit, if the current flows continuously, if the current flows continuously without any interruption, if the current flows continuously without any interruption, which means you don't tamper with the magnitude of that current which is flowing continuously, then the circuit at which that current is flowing is a series circuit. You understand it? If it is continuing, so if it is flowing continuously without any interruption, that circuit is a series circuit. Therefore, if your current is flowing, but it gets to a magnitude whereby that current gets to be interrupted throughout its continuous flow, the nature of the circuit at which that current is flowing, that is a parallel circuit. You understand each other? Which means once you see the current which is flowing continuously get interrupted, just know that that interruption has created a parallel circuit. You understand each other? But the interruption, how it has been interrupted, again, it must be able to come back and form its original form. Your original form, it will be a form of the magnitude, which is the field. Now, I will re-explain that statement based on the second I'm going to draw on the board. Now, I have taken the liberty of taking a bit more complex. It is not too much, but it's a bit more complex, so that we can define when do we see parallel, when do we see series. Now, if you are given a circuit that consists of a source, which is your DC source. Now, we are looking at this analysis looking at the DC source. Now, we have the DC source, which is a battery that will have a positive side and also that will have a negative side. Then the magnitude of this battery then says that is a 5-volt battery. Now, then we ask ourselves this question: what is the importance of that component there. You will see that the importance of that component there, it is to energize the flow of electrons. You understand it? Remember, your flow of current has got two magnitudes. You have got a conventional current and you have got a flow of electrons. You understand each other? You have got a conventional current and you have got a flow of electrons. Now you see that with the flow of electrons, that is when you will have the magnitude which is being energized in that direction there. You understand each other? That is the magnitude or the energized or flow of electrons. Then again we have got a conventional current which is energized, but that energized, it is energized from the positive side of your source. You understand each other? But now, when we are looking at this, how are we looking at this? We are looking at this in terms of your conventional current, which means when your current, it is being energized from the positive side of your baby, which is not your flow of electrons, but your conventional current. We understand each other now. Now, then we will have the magnitude of the circuit, then you will have a resistor with a certain value. Here is going to be 3.3 kilo ohm. Then you will have another resistor which is the 1 kilo ohm resistor. Then you have another resistor which is again the 1 kilo ohm resistor. Then you have another connection there, the resistor, which is a 1 kilo ohm also. Another resistor, which is a 1 kilo ohm. Then you have another resistor, which is 10 kilo ohm. Then this is another resistor, which is a 4.7 kilo ohm. Then a 2.2 kilo ohm. Then we have got a junction there. Then we have got another junction there. Now, microwave electronics. Eh? Come on. Social distancing. Okay, that is the magnitude. Now, with this circuit, we need to define Kirchhoff's law. So, Kirchhoff's law. With this circuit, we need to define Kirchhoff's law. Now, we are going to define this as Kirchhoff based on the voltage divider rule and the current divider rule. The voltage divider rule and the current divider rule. Now, if you are given the magnitude of this circuit, now first things first, we must go and check how is your current flow. How is your current flow? Now, like I said, we are going to look at the flow of conventional current. We are going to do this looking at the flow of conventional current. Now, if you are doing this looking at the conventional current, which means your current is going to be energized from the positive side of the wave, which means this color here will indicate the flow of your current. Now, the current which is going to be energized the current is going to be energized, which means that will be a whole lot of current, whereby it is defined based on how it is leaving this component here. Then we'll say that current, it will be our total current. Because that is the current which is coming from an energizer. That is the current which is coming from an energizer. Now, once we define that, then we go and look at the magnitude at which this current is flowing. We look at the magnitude at which this current is flowing. Now, you will see that this current will flow through the conducting wire up until it sees a junction. Now, once the current sees a junction, what does it mean? It simply means that the magnitude or the original magnitude of that current is going to be tempered. You understand each other? Which means it is not going to be a original magnitude flowing throughout, but a certain portion, depending on the nature of the components which are connected throughout the circuit. Then you can define what is that magnitude. Now you will see that the continuation of this current, when it gets to that point, which is the point of a junction, it is going to split. You understand each other? It is going to split. Now, according to how we understand Kirchhoff, it says on a closed loop circuit. You understand each other? On a closed loop circuit. Now, if the only become a closed loop circuit if your current is energized by a source, move through a connecting wire, then come back to where it started. You understand each other? That is your closed loop. That is your closed loop. Now, it says on a closed loop circuit. Now, if you look at this as a closed loop, now, if it says on a closed loop circuit, if the current gets to be tempered with, which means the nature at which your components are connected, it is what? It is parallel. You understand each other? But now, if you look at these, if the current splits in that direction, and also current splits in that direction, because of the junction on the closed loop, I'm going to say automatically that that circuit is a parallel circuit. I'm going to say that that circuit automatically is a parallel circuit. No. We cannot go and say automatically because how we have initiated this or how we have started this. Remember, if this current and that current, how it has splitted, can come back and rejoin as it is, then the nature of that circuit is what? It is a parallel circuit. Do you understand each other? If this current, how it has splitted, comes back and rejoins as it is, then you can say that circuit is what? It is a parallel circuit. How are you defining this? According to Kirchhoff current rule, according to Kirchhoff current rule, the current entering the junction is equal to the sum of the current leaving the junction. Do you understand it? The current entering the junction is equal to the sum of the current leaving the junction. Provided, I want you to listen to this very carefully, provided that the sum of the current leaving the junction is equal to the current entering the junction. Did you understand that statement? Did you understand that statement? it has got two magnitudes. The current, so let me start it from here. The current entering the junction must be equal to the sum of the current leaving the junction. You understand it? Provided that the current and the sum of the current entering the junction is equal to the current leaving the junction. Can you see that the sum is leaving the junction? Again, the sum is entering the junction. You understand each other? The sum, it is leaving the junction, and then again, the sum, it is entering the junction. The sum, how it has left, it must be the same as the sum, how it is entering. Then, the nature of the circuit where that is happening, it is a parallel circuit. Am I making myself clear about that? Once you can master that, then you're not going to have a problem with a parallel circuit. You must make sure that the sum, how it is living, it must be the same as the sum, how it is entering. Am I making myself clear?
Yes.
How the sum is living, that is how the sum must be entering. Then you can say that is a parallel circuit. You understand each other? Which means here, we can see that the sum is living. You understand each other? We can see that the sum is living. That which means I can say, let's say this one is my I1, that one is my I2. If I look at this junction, I can say that junction, it is a junction whereby the sum, so the current entering the junction, which is your I total, is equal to, the sum of the current leaving the junction. You understand each other?
Yes.
If this statement can occur again, if that statement can occur again, but when it occurs, what must happen? When this statement occurs, what must happen? When the sum now enters the junction. You understand each other? When this sum now enters the junction, then you can go and say the circuit at which that connection, okay, it becomes a parallel circuit. You understand each other? Which means automatically I cannot just go and say that is parallel. You understand each other? I can see that the current is splitting. You understand each other? The current is splitting. But if it comes back and recombine, then I can say that is a parallel circuit. But before I see that, I cannot go and say in conclusion that is a parallel circuit. You understand each other? Okay? Now, then I look at the continuous. Now, if I look at this, is this a closed loop? No. It is not a closed loop. It must be a closed loop whereby the current, when it left the baby, it must come back again to the baby. You understand each other? Then it becomes a closed loop. Then I can say, if I look at the continuation of this, which means now this current is going to flow in that direction, and also that current is going to flow in that direction. You understand each other? But now, while it is flowing, let's see what happens. Then you will see that this one will flow in this direction. When it's flowing in that direction, it sees a component there, which is your resistor. And we know the properties of a resistor, right? You know the properties of a resistor, right? It's not, remember, you said it's not an empty tin. It is a tin filled on a certain level. You have seen this before, isn't it? You have seen this before, isn't it? Okay, cool. You know the properties of a resistor, right? Or you know the characteristics of a resistor when the current is flowing into that resistor, right? Okay, good. Then, how the current is going to enter into this component, that is how the current is going to leave that component. How I agree? How it is going to enter, that is how it is going to leave that component. Which means, if I1 is entering here, remember that is I1, right? If I1 is entering here, which means when it leaves, is it going to leave as a full magnitude of I1 or a certain portion of I1? Is it going to leave a full portion of I1 or a certain portion of I1? It's going to leave as full I1 in magnitude. Okay. In value. Is it going to leave as I1 full value or I1 less value? Full value. Which means also here I'm going to see what? I'm going to see I1. You understand it? Now, the I1 continues. Again, same resistor or same magnitude of the component, which means again here, I'm going to see what? I1. But when I1 continues to flow, what does it see? It sees a junction. It sees a junction. Now, once it sees a junction, what happens? Once it sees a junction, what happens? It's going to split, isn't it? Which means on this junction, what is going to happen on this junction? What is going to happen on this junction? The current entering the junction is what? The current entering the junction is what? Is equal to? Which means I1 is equal to, you will have a split on that direction and also have a split on that direction. Then I can say, let's say this one, it is your I2, I3, and that one it is your I4. Which means here, the current entering the junction is equal to the sum of the current leaving the junction. Which means here, you will have I1 is equal to I3 plus I4. You understand each other? Now, because that analysis, also that network has been created, am I going to say that that network is of a parallel network? Am I allowed to say that that is a parallel network? Because of this junction, with the continuous of the current flow, am I allowed to say that this network is in a parallel network? No. I cannot go and say automatically that is a parallel network. Why? Because I haven't seen the sun entering the junction. Do you understand each other? Have I seen the sun entering the junction? No. I haven't seen the sun entering the junction. Once I see the sun entering the junction, then I can say what? That is a parallel network. We understand each other? Okay? Now, if I do the continuation of this, you will see that I will have this go in that direction, I will have this go in that direction. Now, when this one is coming to this direction, what do you see? When this one is coming to that direction, what do you see? Which means here, also here, what do I see?
Entry.
What do I see? I3. How are you doing that? What do I see? I3. How are you doing that? Okay? When I do continuation of these, here, what do I see?
I4.
What do I see?
I4.
I4. Now, can you see the line where I3 and I4 is? Can you see that line? Where is that line? Where is that line? Can you see where the line I3 and I4 is? Can you see the line of I3 and I4? The line of I3 and I4. Can you see that line of I3 and I4? According to how we are looking at the circuit. Remember, we are not looking at that I3, I4 before. We are looking at I3, I4 after. You understand each other? Now, if you look at I3, I4 after, where is it? It's connected on the negative side of your supply, which means it is returning to what? It is returning back to the energizer. You understand each other? It is returning back to the energizer. Now, the moment your ground line becomes visible, which means your current is not gonna go anywhere except what? Back to the energizer. You understand each other? Because that is the resting point. Am I making myself clear? Now, because we have got this magnitude that is existing here, I3, it's moving back to the energizer. I4, it's moving back to the energizer, which means it is one thing which is moving back to the energizer. You understand each other? Now, would I be wrong? Now, I want you to be honest. Would I be wrong if I say, at this magnitude here, at this magnitude, can you see this magnitude here? At this magnitude here, that is where I have I1 plus I2. That's all.
3 and 4.
I3 plus I4 is equals to
I1.
I1. Would I be wrong if I do?
No.
Would I be wrong if I do? I cannot be wrong. Why? It's because the magnitude of these two is looking at one similar point. Do you understand each other? The magnitude of those two, it is looking at one similar point. So it means my I1 and my I2 has come back and rejoined again. Am I making myself clear? Now, then I can say, therefore, this component and that component, they are parallel to each other. I'm trying to breathe on this thing. Do you understand this? Do you understand this one? How I have drawn the conclusion of this magnitude. Yes? We are not done with the second. No. Don't make that mistake. We are not done with the second. I mean, we are looking at the current flow. Are we done with I total. Remember, your current must be what? Your current must be I total. You understand each other? Your current must be I total. Here we're talking about I1. Let me put it this way. Here, we must have I total. We must have I total. We have agreed I total. You understand each other? Now, would you agree with me that I1 it is part of I total? Do you agree with me that I1 is part of I total? Do you agree with me on that? Good. Now, here I'm still working on the magnitude of I1. Then, up until I1 becomes visible. Where is I1 becoming visible? It is becoming visible on that point there. You understand each other? It is becoming visible on that point there. Now, let me just try to re-explain this in this manner. Here, it must be delivered to a point whereby I1 plus I2 is equal to what? I1 plus I2 is equal to what? I total. We want what has left to become what is coming back. We understand each other? What has left to become what is coming back. Already, we can say I1 is coming back. You understand each other? But I1 never left alone. I1 left with I2. That was splitted from I2. You understand each other? Now, if this magnitude exists, because I3 and I4 combined together, they give you what? I1. The sum of the current entering the junction. You understand each other? Okay? Now, if this sum is entering the junction, then you will see here I've got what? I've got a parallel equivalent circuit. I've got a parallel equivalent circuit. Now, if here I've got a parallel equivalent circuit, then I'm going to create an equivalent resistor. And then you know the formula. How 10K multiplied by 4,7K divided by 10K plus 4,7K, then you get equivalent value. You know the formula? Or you have explained it. You know the formula. You will be able to write the formula. You know how to use a calculator, right? You will be able to punch in the value correctly, mathematical algorithm correctly, and then you press equals to or enter, and you will get the correct value. And you know, because you write online, you know the moment you put in the value there, if it's not a correct value, which means it's wrong, right? No, I just wanted to find out if you need to know. Okay. Now, why didn't this current go there? And then this is a junction. It's a junction, right? It is a junction. I agree on that one. And also that one, it is a junction. I agree on that one. Why didn't it go there? This one. Why did this one didn't go that direction, that one didn't go that direction? Why didn't it go that direction? Why didn't it speed? But it has to rejoin. Why didn't it speed but it has to rejoin? Because it gets to be attracted by where it is coming from. You understand each other? Which means the magnitude of the ground holds more attractive situation than how it is continuation. You understand? The moment the current sees the ground, it sees what? A resting place. You understand each other? Which means they have to continue inflow. If it was another component connected there, it was a different scenario. Okay? Now, we have manipulated that. What are we left with? We're left with I2. You understand that? I2 also exists. But now, when I2 exists, how is it existing, this I2? Then we look at the continuation, which means also here. What do I have? What do I have? I have I2. When I2 is flowing, what does it see? What does it see? It sees a junction. When I2 sees a junction, what does it mean? I'll tell you the reason why I'm doing all of this so that you can understand. When I2 sees a junction, what does it mean? It simply means I am not going to have a continuous flow in terms of value as it is, which means now the magnitude of the value is going to change. Then you will have a certain portion going to that direction and also a certain portion going to that direction. Do you see? A certain portion going to that direction, a certain portion going to that direction. Now, this one, through this component, characteristics of this, then it continues to flow there. Now, here it's going to be what? I5, and so this one is I6. Which means here I will find what? I6, this one continues to flow. Does it see a junction? No. It sees a component. You understand each other? Which means how it is entering this, that is how it is leaving that. Which means also here, what do I see?
I5.
What do I see?
I5.
I5. You understand each other? Then I6 flow in that direction, I5 flow in that direction. When this one and that one they are flowing, what do they see?
A junction.
It sees a junction. You understand each other? If it sees a junction, then it asks itself, is it a splitting junction or is it a combining junction?
Combining.
It's a combining junction. Which means on this junction, the sum of the current entering the junction is equal to the current leaving the junction. Which one is leaving the junction? It is I2 which is leaving the junction. Up to so far, do you understand? So, which means here, that is according to that one there. Then, here, what do you find? You find 2. Can you see what is happening? You find I2. Which means, if this statement, I have seen this statement before. You understand each other? I have seen this statement before. But how I have seen this statement, it was not in this manner. But if I look at the previous statement, I look at this statement. They are similar, isn't it? Which means the network at which this statement has been created, the components which are connected there, they are parallel to each other. Which means here, what do I have? I will have an equivalent circuit. Then you go and create an equivalent component, which is a parallel resistor. Now, if I do the continuation, here I have the what? I2, continuation here. What do I have here? Also I have I2. Can you see? But when I2, the moment I2 leaves this component, what does it see? It sees the negative. You understand each other? It sees the negative, which means it goes and merges itself there. Once this one and that one becomes a sum, it's equals to what? It's equals to I2. What can I say? What is my conclusive decision? Which means that is indeed a parallel circuit.
Do you understand? Do you understand?
Okay. Now,
Can you see that whatever that happened, it happened in terms of if you look at the entire circuit. If you look at the entire circuit, the definition that exists within that network, the definition that exists within that network is a parallel, or it is a series parallel network. It is a series parallel network. If I look at the overall, your overall must be based on what? Must be based on where the combination of how it was energized. The overall based on the combination of how it was energized. That overall is a parallel network. You have splitted from how it left the energizer. You have rejoined how it is coming back to the energizer. So which means its overall, it is a parallel network. Which means your total resistance of the circuit is going to be a parallel total resistance. You understand each other? It's going to be a parallel total resistance. You said you are familiar with the magnitude of how to use your Kirchhoff voltage rule and Kirchhoff current rule in terms of the resistors which are connected here. When they are connected in parallel. This is the magnitude of the formula used. When they are connected in series, this is the magnitude of the formula used. You said you're familiar with that, isn't it? So which means if you were to find whatever that has been asked in terms of Ohm's law, it is not going to be a problem. If they say find the current, find the voltage, it's not going to be a problem. What you need to be able to do is to break down your circuit in terms of the current flow, to know when it is series and to know when it is parallel. Once that it has been established, then you must be able to find one common equivalent component so that Ohm's law can be applied. Now, it is not going to say find the total current of the circuit. It can be placed in a manipulative way of saying find the current which is flowing into 2,2 kilo ohm resistor. Find the current which is flowing into 2,2 ohm resistor. Now, you need to locate where is 2,2. You understand each other? If I locate the nature of 2,2, 2,2 is here. Do I know that I2 is going to flow there? Do I know that I2 is going to flow there? No, I don't. Because I don't know how this current is being energized. So which means I need to follow the algorithm of understanding at which current am I going to end up with there. You understand, Richard? What I'm teaching you is the algorithm of analysis. Now, with the algorithm of analysis, I am trying to break down a complex circuit into a simple understanding of Ohm's law, looking at how Kirchhoff defined the flow of current in an electrical circuit. You understand each other? So which means, if I say to you, find the voltage which is flowing into 4,7 kilo ohm, do I know the voltage? I only know the supply voltage, isn't it? That is the voltage which is used to energize the flow of current. But according to Kirchhoff, it says in an electrical circuit on a closed loop, in an electrical circuit on a closed loop, the sum of voltages across the component is equal to what? Is equal to the supply voltage. You understand each other? It says on a closed loop, the sum of voltages across the components which are connected there. But if I look at the definition of things, would I say this is the sum? No, I cannot say that is the sum. Which means for me to be able to do that, I must be able to complement the current, the voltage rules. You understand each other? You must be able to complement the current and the voltage rule, which means current will give me direction. It will give me clarification. When do I have parallel? when do I have cells? If the current flows continuously, without any interruption, which means I can be able to define the sum of the voltages. Do you understand each other? If the current flows continuously without any interruption, then I can be able to define the sum of the voltages. But if there is a certain interruption which is existing, then the entire magnitude needs to change. I need to look at what is the fundamental understanding. If you look at these, then you will see that whatever that needs to be asked, it becomes easier for me to manipulate in terms of Ohm's law. Whatever that needs to be asked, it will be easier for you to manipulate in terms of what? In terms of Ohm's law. Because I can manage to identify when do I have the continuous flow and when do I have the interruption. Am I making myself clear? Now, you will see that if you do this according to how I have done it on the board, people, again, you can have your own methodology that you can use in order for you to manipulate this. If I were to redraw the circuit, after I've done this, let's see what I've done. If I were to redraw the circuit, I would go and say, now I understand this circuit in this way. I understand this circuit in terms of the supply voltage, which is what? The supply voltage, which is my 5 volt. Do you understand each other? I've got the supply voltage, which is my 5 volt. Then I can go and say, after the supply voltage, then I will have I total, which is continuous. But now, when I say I total continuous, then you will say, it goes and splits. When it splits that direction, it also splits that direction. Which means I can go and say, it is splitting that direction and also it is splitting that direction, which means I've got a junction there. Are we remember? Why am I redrawing this in this way? I am redrawing it in that way because I understand it in that way. Am I making myself clear? I understand this in this way. But how I am looking at this, based on how I have traced my flow of current, which means here I can say my I2 is flowing that direction and my I1 is flowing that direction. Am I making myself clear? If I do the continuation of these, which means I1 will flow, and when I1 flows, what does it see? It sees a resistor. What is that resistor? It's 1 kilo. Can you see it? It's 1 kilo ohm resistor, then continuously 1 kilo ohm resistor. Because I1 flows into that component. After this component is still I1, after that component also it is still I1. We understand each other. Then, when it flows again, what does it see? It sees a junction. Can you see? If it sees a junction, on that junction, what do you see? I see a resistor, and also I see a resistor, which is what? I see a 10 kilo ohm, and also I see a 4.7 kilo. Then
these two join together, which means the continuation of this is just from there. If I give it to you like that, then it becomes easier for you to understand what you know, isn't it? Was it given to you like that? The second, was it given to us like that? No. But that is how I read the second after I understood exactly what he said. You understand it? Then, the second notion of this is what? The second notion of this is what? It is a I2, which is what? 3,3 kilo ohm. Are you agreeing on that? Then, when 3, this is the I2, and also here, what way? I also have I2, isn't it? Then, after this one, what way? I have a junction. On that junction, I have a resistor, and also I have a resistor, isn't it? Which means this resistor is 1K, and also that is 1 kilo ohm. 1 kilo ohm. Then these two, they join together. Are we agreeing on that? The combination of these, I've got a resistor there. Do you agree with me? Which is what? 2,2 kilo ohm. Now, after these, where is this connected to? Back to the source, isn't it? After these, where is this connected to? Back to the source, which means the combination of these two, it comes back to that one there, which means that one goes there, that one goes there. Which one is more simple?
When you are given it to you in which way? If it's given to you in this manner or when it's given to you in this manner? Which one would you prefer? This one or that one? Oh, no, there is one that I'm going to give you as an exercise after I'm done with the one tomorrow. Then I'm going to give you one that I want you to go and do, which is totally different from this, but it needs the same principle. Here, I'm not teaching you how to, or I'm not showing you how to calculate 10 kilo ohm or the voltage across 10 ohm. The magnitude at which, or the algorithm of the magnitude at which you will be able to manipulate within a complex circuit, make it easier for you to understand. If I give it to you this way, 100%. If I give it to you that way, also 100%. Depending on how do you understand to manipulate this. Any question? So which means now you can go and apply the voltage divider. Now can you go and apply the current divider? Can you go and apply the voltage divider or the current divider? If I were to ask you, use the current divider, must be very careful. If it says use the current divider, you must use the current divider rule. We understand each other? If it says use the current divider rule, you must go and use the current divider rule. We know that you know how to use Ohm's law. V is equal to I. No, that will be. But use current divider rule. To find the current which is flowing, use the current divider rule to find the current which is flowing through a certain component. Now, you must be able to manipulate. When do I use current divider rule? What magnitude is needed for current divider rule? And please do not confuse that magnitude. Do not confuse that magnitude. Now, what I've seen in most cases, is if I say to you, use the current divider rule to find the current which is flowing through R3. Can you see where R3 is? Which means, for example, the reason why I'm writing this is so that I've seen it happening so many times, which means that is I3. Now I want the current which is flowing there. I've got a junction there, and also I've got a junction there. You understand each other? Now, I've got a current which means that is your I total. And I'm making myself clear. Which means this current will split there and also to go to that direction. Are we clear? And then continuously, it will split there and also go to that direction. Which means that one can be what? I3, that one can be I2, that one can be I1, because it's going to R1, R2, R3, but we still have that current there. Can you see? But I want the one which is going to R3. If it is three components which are connected in cells, is it right for me to go and say I of R3 is equals to? Remember, it must be the magnitude of the equivalent multiplied by the supply current. But the magnitude of the network, which network? Which supply? Is it the original supply? Is it a supply within the branch? When you do these rules, or when you manipulate the voltage rule and the current rule, you must be very careful at what point are you. You understand each other? You must be very careful at what point are you. Always remember these. The current divider rule will work at its maximum. The current divider rule will work at its maximum when the current is splitting on a branch that is consisting of an element of two components. You understand each other? When you're splitting of the current, it is according to an element of two components. Which means if I consider this one here, which is the flow of current, when this current splits, it splits according to that junction there and also that junction there, and then there's no further splitting. You understand each other? Which means the current divider can work optimally there. Am I making myself clear? Why? Because it says the current divider, it is based on the current at which it has been splitted. This current must be determined based on the current at which it has been splitted. It has been splitted from that junction there. When it is splitted, it had a magnitude going on the other direction. You understand each other? It had a magnitude going on the other direction. But that magnitude which is going on the other direction, we look at the existence of the component there. What is that component? It is what? It is R2. You understand each other? Then it becomes your R2 divided by the sum of the resistance of that network. The sum of the resistance of that network is going to be what? Your R2 plus your R3. Multiplied by the current entering the junction. Multiplied by the current entering the junction. Which current is entering which junction? The junction where I3 is, which is that junction there, that undefined current there. Why it is not I total? Why can't I use I total? Why can't I use I total? Because I total is the maximum current that is being energized from the battery. Why can't I use I total? I cannot use I total because I total it is splitted within 3 junctions. You understand each other? I can only work if it is a 2-way split, which is that split there and that split there. But you see that I total, it goes that direction and also goes that direction. Continuously, that direction there and also goes that direction there. Can you see? Which means when the continuation of this flow exists, it's no longer this as a whole, but only a portion of the head. Do you understand? Are you lost? No, that one is the last question. Are you lost? Are you lost? Have you found your way? Or you still have to go and digest? Am I alone on this? Remember, I'm not writing. I'm not going to write. You're going to write. Isn't it? Is there any confusion which is existing there? Or are you going to ask them anonymously? You're going to ask anonymously? No, you know how to ask anonymously. But say, now I'm seeing the second. What do I do? Where do I go? Why is it I3 there? Why is it I2 there? Why can't it be this? You're going to ask me that? Okay. Okay, thank you very much for the time. And I'm gonna give you a second that you're gonna do. I'm gonna put it on WhatsApp in the group. Not today, tomorrow. After my last session tomorrow, I'll put it on the group. Then you take those seconds. Now, in those seconds, use the voltage divider rule, the current divider rule, for you to find the voltages of the current that exists within the components there. You must exercise using those equations or using those formulas so that you can understand how do I apply it, where, how do I apply it.